Hey Geometry 2 students, Miss Craft here. Today's lesson is 12.3, Using Proportional Relationships. And today's lesson is literally no different than 12.1, I believe. And that is just applying triangle proportionality theorems, basically. Maybe from Unit 11, I really don't remember. But I know you're doing the same thing over and over and over again. So I have 8 examples here of basically real-world type problems. I did 4, and then there are 4 left for you to do if you so choose. The first example that I did is number 1. A surveyor took some measurements to find the length of a pond as shown below. What's the distance from one end of the pond to the other? So I put x here because one end of the pond is p to n, so that's the segment that we're looking for. I used what I know, and that is 3 over 12 has to be equal to 5 over x. Now there are multiple ways you can set up this proportion. I could have done 3 over 5 equal to 12 over x, but you'll get the same answer either way. Completely your choice. I then multiplied each side by x to eliminate my fraction. Remember that fraction bars are just division. The inverse of division is multiplication, so I'm going to multiply to undo all of my fractions. I did reduce 3 over 12 to 1 over 4 because it makes your math a little bit easier. So that left me with x over 4 equals 5. And then I multiplied both sides by 4 and I got 20. This is a word problem, so my expectation is that you would write the answer in words. The pond is 20 meters across. Obviously, when you take your unit quiz or your module exam, most of those are going to be filled in the blank, so you'll just put the number there because I didn't want you to make mistakes based on matching my sentence or whatever. So when you solve word problems, you should answer in words, but on my tests and quizzes, it'll be just the number answer. The next one that I did is number 2. A Greek mathematician found you can measure the height of a pyramid using geometry. Using the diagram below, and then given that a pace is approximately 3 feet, we're going to find out how tall the pyramid is. You were given 2 pieces of information in this diagram, 125 paces from the center of the pyramid to the end of the pyramid, and then 114 paces from the end of the pyramid to the end of its shadow. This 125 paces is irrelevant, so make sure you're only picking out the important information. So I wrote down what we're going to do here, and that is height over height equal to shadow over shadow. I could also do the height of the pyramid over the shadow of the pyramid equal to the height of the person over the shadow of the person. Okay, so again, multiple ways to set up this proportion. Completely your choice, depending on where you want that variable to end up and things like that. So I did x over 2, the height of the pyramid over the height of the person, equals 114 over 3, the number of paces of the pyramid over the number of paces of the person. I multiplied each side by 2 to eliminate my fraction, and I got x is 228 over 3. That does divide evenly, so x is 76 paces. The height of the pyramid is 76 paces. However, that is not the answer because paces is not a measure for height. So I did 76 times 3 because a pace is approximately 3 feet. That gave me 228, so the pyramid is 228 feet tall. Okay, example number 3, very similar to example number 1. 2 cabins are located across a lake from each other, and the distances are not given on the diagram. So the only difference is that you have to fill in the distances yourself. So it's important to be able to read a diagram, basically. From cabin A to the end of the road is 700 yards. And then from cabin B to a point behind the lake is 500 yards. You are then told that somewhere in this lake here is a little fisherman, and he's 780 yards away from cabin B. It's really important that you identify what's being asked. I asked you for the distance from cabin A to cabin B, which means you have to solve for cabin A to the little fisher guy, and then add those values together. Okay, so what I did was I put x for the unknown, and then I did the distances of the ends of the triangles, basically, which they are marked parallel, so I know that alternate interior angles are congruent, vertical angles are congruent, so these are similar triangles, which is why I can set up a proportion. And I have 500 yards over 700 yards equal to 780 yards over this unknown x. I then multiplied each side by x and reduced my hundreds because 500 and 700 just reduces to 5 over 7. And I was left with 5x over 7 equals 780. And then I multiplied each side by 7, and I got 5x equals 5,460. I then divided by 5. It goes in evenly, and x is 1,092. So from cabin A to the point where the fisherman is 1,092 yards. And then you have to find the distance from cabin A to cabin B. So adding that to 780, which gave me 1,872 yards. Okay, again, answering in words, so the distance from cabin A to cabin B is 1,872 yards. The last example that I did is a super common AZ Merit question, and that is using a mirror, because this is really popular for some reason. So a tourist stands, 0.4 meters away from a mirror. He's 1.92 meters tall, and he wants to measure this building here. The mirror, you can see the top of the building, and then the mirror is however many meters away from the base of the building. So you've created two similar triangles, and you're solving a proportion. I have the height of the man, the distance from the mirror. I'm solving for the height of the building, and I have the distance from the mirror. So I did the height of the building, x, over the distance from the mirror, 87.6, is equal to the height of the man, 1.92, over the distance from the mirror, 0.4. So I multiplied each side by 87.6 to get x by itself, and I got x equals 168.192 over 0.4. I divided that, and I got 420.48. So the building is 420 and 48 hundredths meters tall. I kept it at hundredths because you are given a hundredths measurement in the question here. If everything was rounded to tenths, I would have rounded my answer to tenths also. So just pay attention to how questions are being answered, but if I give you anything like this on a quiz or exam, I'll make sure to tell you what to round to. That's all I have for you for lesson 12.3. If you have any questions, please message me in Canvas. Thanks.